Air compressors and spray guns are easy and enjoyable to use for a variety of do-it-yourself applications. And with the modern generation of these energy-efficient air tools, it's now a breeze to paint a wide variety of household projects and have the work look like it was done by a pro. Air compressor tools can even be used for cleaning, polishing, and sandblasting before the paint is sprayed. Let's take a look at the air compressor. It's a power source that is designed to be either stationary or portable. The air compressor that we'll be using is a portable type with wheels and handle. The main parts of the air compressor are the on and off switch, pump motor, check valve, air tank, pressure switch, pressure gauge, pressure release valve, safety valve, air outlet, shut-off valve, and drain valve. The on-off switch turns the pump on and off. The pump creates air pressure when the air compressor is operating. The check valve opens to allow the compressed air to enter the air tank and closes when the air pressure reaches its capacity. While the motor is off, pressure in the air tank drops as you spray paint. When the tank pressure is at a certain low level, the motor will restart automatically. The pressure switch automatically starts this low pressure, and it stops the motor when the air pressure reaches maximum pressure. This pressure is indicated on the pressure gauge. The pressure release valve is located on the side of the pressure switch. It's designed to automatically release compressed air from the compressor head and outlet tube. It allows the motor to restart freely. The safety valve protects against high pressure by popping out at a factory set pressure level. The air outlet is used to attach air hoses to the air compressor. The shut-off valve is used to shut off the flow of air from the compressor. The drain valve is used to periodically drain water which condenses in the air tank. Many compressors are permanently lubricated, while some require oil being added to the crankcase. Check the oil level in the crankcase daily. There are a few important factors you should look at before selecting an air compressor and a spray gun or other air tools. Spray guns are available in a variety of models. Some are designed for general purpose applications. Others are for specialized applications like spraying lacquers. As you read the factory description of a spray gun, you should note the references to horsepower, SCFM, and PSI. Air compressors are available in a range of horsepowers. Generally, the air tank models for home use range from 1 to 5 horsepower. Choose an air compressor based upon the type of work to be done. If you paint infrequently and paint only for short periods, then a lower horsepower compressor is adequate. However, if you are continuously painting larger objects or spraying lacquers and enamels, then a higher horsepower compressor should be used. SCFM, or standard cubic feet per minute, is the measure of air delivery from the compressor. A higher SCFM forces more air through the hose, and this allows more paint to be sprayed in a given time and increases the number of tools that can be operated by the compressor. When choosing an air compressor and spray gun, choose an air compressor equal to or greater than the SCFM of the spray gun. Generally, air compressors with more horsepower have more SCFM than those of less horsepower and are better able to produce the air pressure necessary to atomize paint. And there are many different types of spray guns that have different SCFMs ranging from 2.5 to 9.6 SCFM. PSI, or pounds per square inch, is the air pressure output of the compressor. Higher PSI allows a heavier body paint to be sprayed and more effective operation of many air tools. Air compressors have specific PSI output ratings, and the PSI is adjustable by using a pressure gauge and regulator. Spray painting requires that the pressure be set at no greater than 40 PSI. Now, consider the SCFM specifications for several different air compressors. This 2.5 horsepower unit has a 12-gallon air tank and delivers 7.5 SCFM at 40 PSI. This 3 horsepower unit has a 15-gallon air tank and delivers 8.5 SCFM at 40 psi. And this 5-horsepower unit has a 15-gallon air tank and delivers 11.3 SCFM at 40 psi. As you can see by the different specifications, it's important to match the spray gun and air compressor SCFM with the type of work you are doing. Let's now set up the air compressor before we paint. These air compressors are portable and can be moved to any job site. However, it's always best to keep the air compressor near an AC outlet and not use extension cords. Extension cords can lead to a voltage drop, which could cause the motor to overheat or fail to start. If possible, have a dedicated circuit of at least 15 amps for the air compressor. If you can't have a dedicated circuit, keep the circuit free of other electrical demands. If there is no AC outlet close by and you must use an extension cord, then use one which has a 3-blade grounding plug. Use a 12-gauge AWG or larger cord. Do not use 14 or 16 AWG cords. Be sure the extension cord is in good condition and no longer than 50 feet. We recommend using additional air hoses instead of extension cords. Air hoses are available in 1/4 inch, 5/16 inch, and 3/8 inch diameters, and 25 and 50-foot lengths. Hoses are also available as either straight or coiled. It really is a matter of personal choice. We'll be using a 3/8 inch diameter, 25-foot hose for our work. We also recommend that Teflon tape be used to seal all threaded fittings for filters, regulators, and hoses. Nothing is more frustrating than to have moisture and dirt-contaminated air coming through the spray gun. The sprayed surface will look dirty, mottled, and blemished. Condensation comes from 2 sources. If the air in your shop or area is humid, then moist air is drawn into the air tank. The air in the air tank is warmed from motor pump activity and cools while not being used in the air hose. This warming and cooling produces moisture. That is why you can continuously spray paint all morning with no moisture problems. Then after lunch, notice moisture coming from the spray gun. To avoid this problem, we recommend that an inline filter and regulator be used as near the spray gun as possible. Attach the filter and regulator to a wall-mounted board and not directly to the air compressor. Connect a hose from the air compressor to the filter so that the hose is bowed toward the floor. And connect a hose from the regulator side to the spray gun. The reason for the draped hose is to allow any moisture from the compressor to settle at this low point. The hose can then be periodically disconnected from the filter and blown out. And remember to routinely drain and clean the filter. If you're working in a remote location, it is still best to install the filter and regulator near the spray gun. Mount the filter and the regulator to a piece of 3/4 inch thick plywood and clamp this onto a stepladder near your work area. If you're using long lengths of air hose, you can expect some pressure drop at the output end of the hose. However, this can be easily compensated for by increasing the PSI output with the regulator. Simply squeeze the spray gun trigger just enough to blow air through the gun, but not enough to spray paint. While air is blowing out the gun nozzle, adjust the regulator to the desired PSI. Hoses are attached to the air compressor, filters, and spray guns with connectors. Some connectors permanently attach the hose to the tool. However, the connector called a quick connector makes hose connections a snap. They make it very easy to remove spray guns for cleaning, changing to other tools, or adding more hose. Quick connectors are made up of 2 parts, the stud and the coupler. The stud is threaded to the spray gun, and the coupler is threaded to the hose. To use the quick connector, simply slide back the spring-loaded slide on the coupler, insert the stud into the coupler, and release the slide. Before we begin any work on our projects, there are safety rules to review. Read the owner's manual for any tool. Be familiar with tool parts, uses, and procedures. Remove all jewelry and tuck long hair under a cap. When using any electrical tools, avoid wet or damp areas. Wear safety goggles or a face shield when sandblasting, power washing, blowing air, and painting. Wear gloves when working with rough or sharp-edged material or when sandblasting. Wear a filter, vapor mask, or respirator when sandblasting, scraping, wire brushing, painting, or spraying toxic or hazardous vapors. Always unplug the AC cord and release the air pressure from the tank when attaching accessories or before doing tool maintenance. Keep your work area clean and neat. Spray paint in well-ventilated areas. If a venting fan is used, it must be an explosion-proof fan. Read the labels on all paints, finishes, and solvent products. Follow all handling and cleanup procedures. Never use tools when you are tired. Never use tools when under the influence of medications, drugs, or alcohol. Don't overextend yourself when standing on a ladder. Observe all safety procedures which are included with the ladder. Certain parts of the compressor, such as the motor head and tubes, get hot when the compressor is running. Never touch these parts during or immediately after operating the compressor. Never operate the compressor with the belt guard removed. Never exceed factory recommended air pressures for the air compressor, spray guns, or other air tools. Never tamper with or in any way modify the air compressor or its controls. Do not adjust the pressure switch setting and do not defeat the safety valve or replace it with one set at a higher pressure. Do not repair, drill, or weld a leaking air tank. These will weaken the tank and can cause tank explosion. Leaking tanks must be replaced. Never point any nozzle or sprayer toward a person or any part of the body. Never inhale the air produced by the air compressor. Never smoke while spraying. When spraying lacquers, varnishes, stains, or other liquids which have a flammable solvent base, never spray near an open flame, water heater, sparking electric motors, or any other source which could ignite the volatile fumes. Do not use any type of spray coating material containing 1,1,1-trichloroethane and methylene chloride. Do not use these solvents for equipment cleaning or flushing. These chemicals can react with the aluminum used in spray equipment, spray guns, and cup to produce an explosion hazard. Surfaces have to be prepared before any material is sprayed. Accessory air tools are the blowgun, power washer, and sandblaster. Use the blowgun to remove sanding dust, loose paint, sandblasting waste, or any other debris. Sometimes it is not enough to blow the dirt away. You have to wash the surface. The power washer is ideal for cleaning grime from almost anything, including house siding and greasy or dirty garden tools. We're using the power washer to wash both this bicycle and window shutter before they are painted. The power washer is designed so that it can be adjusted to spray only air, only water, both water and air, or both air and chemicals. You should dilute any soap or degreaser with water in a bucket to achieve precise control of the chemicals. The chemical solution should have a viscosity similar to water. The power washer requires air pressure of 40 to 175 psi and water pressure of 20 to 100 psi. The water temperature should be less than 140 degrees Fahrenheit. Removing rust and scaling paint is a real chore, and it takes a lot of elbow work if you use brushes and scrapers. However, the sandblaster makes it easy to prepare your projects for paint. We're using the sandblaster to remove rust from this mailbox, table, garden tool, and boat trailer. And we're removing old paint from this window shutter. There is a variety of sandblasting abrasives that you can use to clean wood, metals, brick, and concrete. Use sand sieve size 20 to 40 for general purpose work. This sand is useful for removing light rust and paint from metals, wood, brick, and concrete. Use sand sieve size 50 to 100 for a more polishing type of finish. It produces an antique wood finish and cleans tools and auto parts. Use aluminum oxide abrasive material to remove heavy rust and rough surface paint. And use walnut shells, pecan shells, or corncob meal for cleaning wood. The basic elements of the sandblaster are the hopper, the cover, and the hopper screen, the gun, nozzle, and material hose. When setting up the sandblaster, connect one end of the material hose to the connector on the bottom front of the hopper, and do not cover the hole located in the connector. Attach the other end to the gun. The air hose is connected to the fitting at the bottom right of the gun butt. When using the sandblaster, high air pressure and working close to the surface will help get the job done faster. Store blasting material in a dry location and always filter it to remove any caked material and other matter from the previous blastings. Reused material must be free of debris to prevent clogging of the gun. As the nozzle wears from use, it will be necessary to adjust the air pressure and distance from the work. Replacement ceramic or tungsten carbide nozzles are also available. Use a booth such as a cutaway cardboard box when sandblasting small objects. This will prevent scattering of abrasives and it traps the abrasives for reuse. Use the lowest effective air pressure possible when working on soft wood to prevent blasting damage. Do not use the sandblaster near automobiles, glass, furniture, or other items that may be damaged by overspray of abrasives. When removing paint on metal, set the air compressor from 50 to 125 psi and use 20 to 40 sieve size abrasives. The gun tip should be 1 to 4 inches from the work and the blast angle should be about 90 degrees. When removing paint on wood, set the air compressor from 40 to 125 psi. Start with a low pressure and work to a higher pressure. The gun tip should be 1 to 6 inches from the work, and the blast angle should be about 45 degrees. Use ground pecan shells, corn cob meal, or ground walnut shells as the abrasive material. Use a brushing motion and stop when the desired finish is attained. Use care when sandblasting wood. Watch for any signs of heavy wear on softwoods. Now that we have prepared our projects, let's take a look at the spray gun and the parts which make it work. The cup holds paint and, depending upon gun model, attaches to the gun either with a yoke or it is screwed onto the gun shroud. The fluid tube is bent so that it can siphon out paint even when the gun is tilted. The gun trigger and handle are designed for easy start and stop painting control. In front of the trigger is the fluid needle packing and the packing retainer nut. At the front of the gun is the retaining ring, air cap, fluid tip, and baffle. Different air caps are used for either siphon feed or for internal pressure feed. More on this in a bit. At the rear of the gun are the air valve assembly and the fluid needle adjusting screw. These control air and fluid flow. Both of these elements are adjusted according to the type of paint sprayed and are used to get the correct spraying action. Like all tools, there are terms unique to spray guns to distinguish their types and uses. First of all, guns can be bleeder or non-bleeder types. Bleeder type guns have no air valve and are used with compressors without regulated air pressure. There is always a certain amount of air escaping through the gun. Trigger action only releases the paint. Non-bleeder type guns are used with compressors with tanks and are regulated to maintain constant pressure. Non-bleeder guns have a valve which shuts off the air when the trigger is released. Siphon feed guns have the stream of compressed air creating a vacuum in the cup. This is recommended for use with light-bodied enamels, lacquers, stains, and varnishes. Pressure feed guns have air caps which divert the air pressure down into the cup and into the paint. The paint is forced through the spray gun by air pressure from the tank or cup. This is recommended for use with heavy paints and latex. External mix means that the air and material are mixed outside the air cap. Both suction and pressure feed guns usually are of this type. External mix caps are best suited for quick-drying enamels and lacquers where a high-quality finish is required. Internal mix means that the air and material are mixed inside the air cap. This type of cap is normally used for thick paint, where fast production is desired and where quality of finish is less important. Internal mix must be used with pressure feed setup. Internal mix delivers less overspray and needs less air volume than external mix, and are not recommended for fast-drying paints or high-quality finishes. Let's take a look at several spray guns that you may choose to use for your painting. Model 15501 is a smaller capacity spray gun which bridges the gap between a full-sized gun and an airbrush. It requires 2.5 SCFM at 30 psi and is ideal for touch-up and smaller projects. Model 15510 is a general-purpose gun that can be used with the most common types of paints. It requires 2.5 SCFM at 40 psi and is designed for medium-duty general-purpose painting. Model 15513 is a medium-duty general-purpose gun that can be used with all types of fast-drying paints. It requires 2.7 SCFM at 40 psi and is a general-purpose gun that can also spray paint automobiles. Model 15514 is a general-purpose spray gun used for most household jobs, including painting lawn tools and automobile touch-up. It requires 4.5 SCFM at 40 psi and is used with all types of paints. Model 15515 is a high-performance gun designed for automobile and refinishing uses. It requires 8.3 SCFM at 40 psi. It is used with fast-drying or medium paints. Model 15518 is a high-performance industrial quality spray gun designed for high-quality work and automobile refinishing. It requires 9.6 SCFM at 40 psi. It is for use with acrylics, primers, lacquers, automotive metallics, and other light and medium viscosity finishes. Let's start out with a few generalized painting procedures. Different painting and finishing products have different solvent bases. Always use the correct solvent for cleanup purposes. The common solvents are water, lacquer thinner, and mineral spirits. Please read and follow all paint, finish, and solvent product labels. Apply a primer coat or sanding sealer when painting metal or unfinished wood. Primer coats will seal the material from moisture and provide a better surface for paint. Apply sanding sealer to unfinished wood before spraying lacquer. Sanding sealer will smooth out the surface, fill in pores, and give a better surface for lacquer. Always read the paint or finish labels for specific primer and sealer requirements. Paints and stains should be thoroughly stirred before pouring them into the spray gun cup. Also, check to see if the type of paint or finished product being used should be strained through a filter before spraying. Use a viscosimeter to test for the correct thinness of paints, lacquers, and varnishes. This will help you to spray paint without runs, sags, or globs. Use masking tape and newspaper to cover over areas not to be painted. Remember, remove the tape and paper only after the paint has dried. Most guns require 40 or less psi for operation. Adjust the regulator outlet pressure accordingly. Too much air pressure will damage the spray gun, and it can cause an uneven paint pattern, paint runs, and sags. Some spray guns can be converted to pressure feed. This is useful if the spray material is too heavy for siphon feed or if a faster spray action is desired. To change the spray gun to pressure feed, unscrew and remove the cup from the gun. Unscrew the shroud retaining ring sleeve until the shroud can be pulled down and is free to rotate. Rotate the shroud until the pressure arrow is facing forward, away from the handle, and hand tighten the shroud retaining sleeve. When using the spray gun in the pressure feed mode, air pressure should not exceed 50 psi, or you risk bursting or damaging the spray gun. To operate the spray gun, shut off the fluid flow through the gun by turning the fluid needle adjusting screw clockwise as far as it will go. Do not force it. Keep the air pressure as low as possible. Open, that is, turn counterclockwise, the air valve assembly until the first thread is flush with the back of the gun. This is the full open position. Hold the trigger back and gradually open the fluid needle adjusting screw until a desired pattern is obtained. Trigger the gun quickly in 1 second on and off bursts. spray a small test pattern. Adjust the correct balance of air out of the nozzle and the volume of paint blown out of the nozzle. If the gun sprays too fast and the paint runs or sags, lower the air and fluid pressure. If the spray is too slow, increase the pressure. If there is excessive overspray, then reduce either the air pressure or move closer to the work surface. The kind of finish that you want to apply, whether it is a thick latex paint, lacquer, or stain, will require different spray gun adjustments and different spraying techniques. Always test the spray pattern before you begin work. Hold the gun perpendicular to and 6 to 8 inches from the surface. Follow the contour of the surface. Don't arc the strokes. Move the gun parallel to the work and overlap each stroke 50%. Most spraying should be done with horizontal strokes. Keep the gun at right angles to the surface at all points along the stroke. Move your arm, not your wrist, when spraying. Spray edges and corners first. This will reduce overspray while providing good coverage on corners. Ends are feathered by triggering. That is, begin the stroke before pulling the trigger, and release the trigger just before ending the stroke. When spraying curved surfaces, hold the spray gun at a distance of 6 to 8 inches, but use a curved stroke. When spraying small objects, such as this duck decoy, drive a couple of nails through a scrap board. Turn the board over and rest the object on the nail points. Also, place the object in an oversized cardboard container. This will help minimize overspray and keep airborne dust from settling on the sprayed surface. If you want to spray a stencil pattern on a mailbox, use stiff paper for the stencil. Make the stencil large enough so that you can hold it during spraying. Keep the gun aimed straight at the stencil pattern so that the spray won't bleed under the paper. There are a few problems to watch for when setting up the gun. If you get a spray pattern shaped like a vertical football, then you are spraying too much material. Just reduce the fluid flow or increase the air pressure. If you have a jerky or fluttering spray, then there are several possible problems. The fluid tip may be loose, or the tip seat may be damaged, or the gun and cup could be tipped at an excessive angle. The needle packing could also be dry or worn, or the needle packing nut could be loose. There could also be insufficient material, or the material may be too thick. To remedy the fluttering spray, first tighten or replace the fluid tip or tip seat, and then lubricate, replace, and tighten the needle packing nut. Be sure the gun is not tipped at an extreme angle, and either thin the spray material or change the spray gun to the pressure feed mode. A common problem is a thick and dimpled flawed surface called orange peel. Orange peel can be avoided by keeping the gun at the correct distance from the surface, properly mixing and thinning the material, properly setting the air pressure, and properly preparing the surface. Spray guns require maintenance in order to operate properly. Thoroughly clean the spray gun after each use. First, turn off the air supply or uncouple the air hose. Then remove the cup from the lid. And empty the material from the cup. Rinse it with clean solvent and pour the solvent out. Refill the cup with fresh solvent and attach it to the lid. Remember, always clean with reduced air pressure. Air pressure no greater than 15 to 20 psi will allow quick and thorough cleaning of cup and gun. Recouple the hose or turn on the air supply. Spray solvent through the spray gun. While spraying, shake the gun up and down to remove all excess material from the lid. Repeat this process with clean solvent until all traces of material are removed. Now, turn off the air supply or uncouple the gun so that you can clean a few of the inside parts. Clean the vent orifice and interior of the lid assembly. Then reassemble the gun. Wipe the outside of the spray gun and cup with a solvent-soaked cloth. Do not immerse the gun in solvent. This will wash out valve lubricants and dry out the packings. To clean the air cap and fluid tip, remove them and soak them in a suitable solvent. Then wipe clean with a cloth. If the holes are plugged, use a wooden toothpick to remove any material particles. Never use a needle or any other metal object, as this may damage the holes and result in imperfect spray patterns. When reassembling, don't over-tighten or cross-thread the fluid tip into the gun body. If water is used as a solvent, spray paint thinner or mineral spirits through the gun after cleaning to remove any excess moisture and to protect parts. After cleaning the spray gun, apply a few drops of light household oil to the fluid needle next to the packing retainer, on the threads of the air valve assembly, and that part of the valve stem which protrudes from the gun body. Today's air compressors are energy efficient, portable, and easy to operate. The air compressor offers you a shop full of options in a single package. You'll save time and money by cleaning, power washing, sandblasting, and spray painting. And the air compressor and spray gun will give you a great-looking professional finish that you did yourself. Happy painting!